So let's use exponent rules and the distributive property to explore multiplying polynomials. Now remember our exponent rules where x to the a times x to the b equals x to the a plus b, and x to the a divided by x to the b equals x to the a minus b. And then also let's remember what is our distribution property or distributive property. Remember, when we have something like this, 3 times a quantity, 2x plus 1, I multiply that 3 into both terms of the expression in the parentheses. So we get 3 times 2x plus 3 times 1, which gets us 6x plus 3. Now, let's take another example. Suppose I had x squared times x cubed plus 2x to the first. Okay, so I can distribute the x squared. So we'll distribute that x squared, and I'm going to put it in back of each one of these terms. So I have x cubed times x squared plus 2x to the first times x squared, which gets us x to the fifth plus 2x to the third. Now, if I would have put it in front, then we'll get the same thing, but we have to use our commutative property very quickly. So here we're going to get our x to the fifth again, just like we got up here, our x to the fifth. But this time, before I do this, I take these two and flip their places, so make it 2x squared times x to the first, and then I get my x to the fifth plus 2x to the third, just like I got here. Okay, now you try an example here, and why don't you take 4x squared times 6x plus 5x to the fourth and see what you get. So stop the tape and do it. And you should have got 24x to the third plus 20x to the sixth. Okay. Now let's go on to another problem. I can even use my distributive property when I work out this division problem. You see, all of this, 5x cubed plus 6x squared, is being divided by x squared. So I'll divide first here, and then I'll divide here, just like I would distribute multiplication. So I'll the same way distribute division. So I end up with x cubed over x squared plus 6x squared over x squared. Now, right away, you can probably take a shortcut and get 5x plus 6 as your answer. But in case you're not quite seeing that, so let's follow the rule. 5x to the 3 minus 2 plus 6x to the 2 minus 2, which leaves me with 5x to the first plus 6x to the 0. But remember, x to the 0 equals 1, so this is 6 times 1. So my final simplified answer is 5x to the first plus 6. Same thing we got here, and you don't need to have that 1 there. Okay. Now let's go to another kind of problem. Let's look at the way we multiply, and let's take this problem 32 times 24. Now, instead of doing it like the way we've always done it by hand, like that, or better yet, a calculator, do it like this. 32, we're going to use this problem to show how we can multiply a binomial times a binomial. So I've got 24, which I changed to 20 plus 4 times 32. I'll multiply that 32 in here. I'll distribute that. So I get 30, I get 20 times 32 plus 4 times 32. And 20 times 32 is what, 640 plus 128. So I end up with 768. Now, I don't really care that much about these numbers, but what I want to show you is how I split up 24 and then multiplied or distributed that 32 in there. Now, let's do the same thing with this problem, and I'll put it over here. X plus 2 times 3x minus 1. Now, just like we split up the 24, now we're going to split up this 3x minus 1 so that my x plus 2 is going to get distributed into there and into there. So I get 3x times x plus 2 minus 1 times x plus 2. So then my 3x gets distributed right here, and I end up with 3x times x plus 3x times 2. Okay. Now notice I'm putting that in the front. Probably would have been easier for you if I would have put it in back. And then the negative 1. So I have plus negative 1 times x plus negative 1 times 2. So I get 3x squared plus 6x, 3 times 2. Use my commutative property and flip these two around. Minus 1x minus 2. 6x and 1x are like terms, so I get 3x squared plus 5x minus 2. What do you think of that problem? Why don't you go ahead and try one? Try this one. Take 3x plus 5, and that's going to be times 4x plus 6, and let's just start it again. Take that 3x plus 5 and spread that 4x plus 6 apart. And move that 3x plus 5 into there, and then move it into there. See what you get. So taking that 3x plus 5 in here and then over here, and we get this situation. Multiply the 4x times the 3x plus 5 and multiply the 6 times the 3x plus 5, and we get that situation, which all becomes that. Now let's take a look at another number problem, 35 times 42, but instead of doing it the old elementary school way or even using our calculator, we'll divide it into 30 plus 5. We'll split both numbers apart, and 40 plus 2. So now when we go 2 times 5, we get 10. 2 times 30, we get 60. 40 times 5, we get 200. And 40 times 30, we get 1200. So we put all this together and we get 1200 plus 260 plus 10. So we end up with 1470. Now let's try it with a problem like this. So take x plus 2 times 3x minus 1. And let's try to do similar to what we did here. So negative 1 times 2 is negative 2. Negative 1 times x is negative x. 3x times 2 is 6x. 3x times x is 3x. x squared. So I put all that together and I get 3x squared plus 5x minus 2. Now, I could have done those another way, and this is another way that's oftentimes used, and it's called the FOIL method. And here's where they're getting the FOIL method. The FOIL method is just like this. So I'm going to go x plus 2 times 3x minus 1. So notice how each term multiplied by each other term. This term went by both of these terms. This term went by both of these terms. Well, let's do the same thing, but in a horizontal way. So this I'll call the F. This I'll call the L. And this I'll call the I for inner. And this I'll call the O for outer. So I've got the first terms of each. I've got the last terms of each binomial. Then I've got this cross section, the inner and the outer. Put all those together and I get the word or the acronym FOIL. So x times 3x is 3x squared. 2 times negative 1 is negative 2. I'll put that at the back. The outer, x times negative 1 is negative 1x, and the inner, 2 times 3x is 6x. Putting it all together, and I get 3x squared plus 5x minus 2. Now you try it either way, either that, one over the other way, or the FOIL method. Go back and see what you get. Well, if I use the FOIL method, I'll have 12x squared over here, and in the back I'll have 6, and here in the middle I'll have positive 9x minus 8x, so I'm going to get 12x squared plus 1x minus 6. Now notice something about this FOIL method, and that is in this problem, a plus b squared, I can rewrite as a plus b. Oop. And when I FOIL this, I get the first is a squared, the last term is b squared, and then look at these two middle parts, b times a or ab, a times b or ab. So there's two ab's. So whenever I have this situation, a plus b squared, it's just the first squared, the last squared, plus 2 times a times b. So if I have x, 2x plus 3 quantities squared, all I have to do is square the first, which would be 4x squared, square the last, which would be 9, and then 2 times 2x times 3. 2 times 2 times 3 is 12. 12x. There we go. Okay, now we'll pick this up here in the next video.